Hi, I'm Ryan, and this is Adam, and today we're at Roush CleanTech's manufacturing facility in Livonia, Michigan. This is where we produce and build engines for Blue Bird school buses, Ford commercial vehicles, and fuel systems for both of those as well. Today we're here to talk about the new exciting engine from Ford, the 7.3-liter V8. This is going to be the underpinning of everything Ford has in their medium-duty lineup, and also the Blue Bird Vision school bus.
So you've probably heard about it, you may have read about it. This is really a beast of an engine. Codenamed Godzilla when it was in development at Ford. Roush CleanTech has had thousands of hours in testing and validation with engine, whether it be on the dyno, in the Nevada desert doing gradability tests, in Bemidji, Minnesota doing cold weather development. This engine really is ready to go to market in the school bus business. So Ryan, after such a great run with the V10, why was the purpose for Ford switching to this new engine?
Well, that's a great question. The V10 was produced originally in 1997, and it underpinned everything that Ford had in the medium-duty platform, including the Blue Bird Vision school bus. That led to the development ground up of the 7.3-liter V8. So the question begs, why did they do it? So Ford wanted to take all the feedback they had from all these commercial users that have thousands of vehicles in their fleet, get all of their feedback and incorporate it into the core design of this engine. What did their customers ask for? Well, they gave the feedback that they wanted fuel efficiency and fleet efficiency. They wanted a compact design. They wanted simple serviceability and especially wanted long-term durability. So they took all of those things and really packaged it together to give us the next generation of medium-duty engine from Ford. All of these boil down into a couple talking points that we call cleaner, leaner, and meaner to capture all those attributes of this engine. So what do we mean by cleaner when we look at the 7.3-liter engine? Well, first of all, with our LPG certification, or propane, we're certified to optional low NOx level at standard of 0.05. That's 75% cleaner than the federal standard. If we look at all the constituents across the board that come out of the tailpipe, we're 70% cleaner than the federal standards today with this engine. So this engine really gives us a lot of future proofing. We look at the different difficult steps coming down the road from the EPA and California Resource Board, and really gives us a head start on all of that. Another specific factor to really look at is CO2. That's going to be a big factor going forward and a big focus of the air agencies. If we look at this engine compared to the predecessor, the 6.8-liter V10, we see about a 10 to 15% improvement on CO2 coming out of the tailpipe versus the other engine. And now we do that while still making more horsepower, and Adam's going to talk to you about how we do that a little bit later. But the important thing about CO2 is it serves as somewhat of a surrogate for fuel efficiency. So that really takes us and leads us from cleaner into leaner. With that 10 to 15% CO2 improvement, we believe that our fuel efficiency should be very similar to the outgoing V10, and it should be very close or a little bit better than that on an equivalent usage to the 7.3-liter V8. So we're looking for a little bit of an improvement there. Adam, can you tell us a little bit about the other parts of the engine that are leaner?
Yeah, sure. So diving a little deeper into leaner, and that's great that you went into the CO2 number, because as we go forward in these changing emission numbers, that CO2 number is going to become even more important than NOx, I think. So that's great that this engine really is future-proof, like you mentioned. So let's talk about leaner. So the one big difference, obviously, this is a V8 versus a V10. You have 2 less cylinders, but that doesn't mean less power. Ryan is going to go into the power numbers a little later. But one thing that's really great about this engine and really lends to a simpler design is cam and block. So you've got a single camshaft in the block of this engine. So that cam and block design, much simpler. Really, that's an example of old school meets new school in this engine here. So again, smaller, lighter. We saved 80 pounds on this new engine. So the V10, 620 pounds. This new V8, 540 pounds. That's going to lead to better fuel economy. And it's also a smaller engine. You might have noticed here, well, if you had a V10 next to this, it's about 10% less on the height, 10% less on the width, which makes it a lot easier to service when it's in the engine compartment. We've moved some things around on this engine to make it easier to get to. One thing on the top of the engine you'll notice here, this is the fuel rail pressure control module. On the V10, it was mounted closer to the back of the engine. This is a key diagnostic component, so you're going to want to get to this. Having it forward of the engine makes it easier to get to, and the fact that the engine's smaller, everything together just makes this much easier to service. Another thing that's really revolutionary about this new engine is variable cam timing. While variable cam timing isn't anything new, it is new to the school bus business. So what you're going to have here with variable cam timing is whether you need to idle sitting at a bus stop or you need to really get on the throttle to get on the highway, that cam speed is going to change based on the duty cycle that you need. So great for the school bus duty cycle and great for the reliability of this engine.
I think while we're talking about serviceability, we could talk too about the maintenance on the 7.3-liter V8. If you're familiar with the other Ford engine platform that was out there, the 6.8-liter V10, it's going to be more familiar than not. If we look at things like the oil change, the oil filter, which is located down here, is going to be the same oil filter that's used today on the 6.8 liter V10. In fact, it's the same oil. The only thing that's changing is the capacity. So 7 quarts becomes 8 quarts on the 7.3 liter V8, but even the oil change interval of 5,000 miles remains the same. Moving over to spark plugs, you have 8 spark plugs on this engine versus the 10 on the V10. They're all located down by the exhaust manifolds here on the side of the engine, and they're all powered by independent coil packs which are mounted on the valve covers. Each of these spark plugs has a rating of 60,000 miles, which they need to be changed, which once again, the same to what you're used to on the 6.8 liter V10.
So jumping back to serviceability, because maintenance and serviceability really go hand in hand. This new 7.3 liter V8 has a much simpler belt design. You've got 2 sheaves instead of 3 that was on the 6.8 liter V10. And some optional components that you might have on this engine would be air pump, air conditioning compressor, second air conditioning compressor. And you can see overall a much simpler design, much easier to service. So going back to the serviceability and maintenance aspect, what's important as far as powertrain matching, Ryan?
Ford 7.3 liter V8 is once again matched up with the Ford 6R140 transmission. Now this is unique in not only medium duty truck, but also school bus. Typically what you have is an engine manufacturer of one type and a second manufacturer of a different type for the transmission working together as a powertrain. The Ford strategy is to take a Ford engine and transmission and have them controlled by a single power pack or powertrain control module. This gives us a lot of advantages. One, you don't have 2 modules trying to talk to each other electronically. The other thing is from a diagnostic standpoint. It gives you commonality of diagnostic software for the entire powertrain for the vehicle versus having individual softwares to use.
So let's jump into meaner. What makes this engine meaner? So the first number that jumps out at everybody, the number that everybody wants to talk about, is horsepower. This engine puts out 350 horsepower in a school bus application at 3,900 RPM while producing 468 foot-pounds of torque. Both of those numbers are higher than the 6.8 liter V10. So why don't you tell us about how this engine makes that power, Ryan?
That's a great question, Adam, and it really goes down to the core design of the engine itself. It's built from the ground up to be more powerful, more robust, more durable. So first of all, we look at the cubic inch displacement, right? 7.3 liters equates to about 445 cubic inch. That's, although we're down 2 cylinders, we're up in overall displacement from the V10. So that's one way that we're able to make power. The other way really is kind of the hidden secret, which is the compression ratio. And if we look at the compression ratio of the engine, we're going from 9.2 to 1 on the 6.8 liter V10 to 10.5 to 1 on the 7.3 liter V8. Not only is that better than the predecessor to this engine, but it's also the best in class for internal combustion for school bus and medium duty. So a big improvement there. That helps us with overall efficiency and power density in this engine, taking not only advantage of the full cubic inch displacement, but also maximizing it in that cylinder space. So that's how we're able to get up to that higher horsepower rating at not only a max RPM, but a lower RPM than we're able to do it on the 6.8 liter V10. So more power, less work on the engine.
Absolutely, and that higher compression ratio also helps with low end power, right?
Absolutely. And so the low end power helps you come on and stay efficient. We talked about that a little bit when we talked about the efficiency, the lower CO2 number. But when we're looking at this engine overall, some of the other design characteristics that you could see is obviously 2-valve design, which is down from the valve from the 6.8 liter V10, which had a 3-valve design. But you could see oversized valves on this. So the intake valve here and the exhaust valve that you can see here measuring in at 2.17 and 1.67. So very large valves for a 2-valve pushrod design engine. So a lot of flow going into that, whether you're talking about the intake coming in or the exhaust going out. Tremendous amount of flow through that big cubic inch displacement engine.
Absolutely. So Ryan, it sounds like this engine is a bid block in every sense of the word. So how do you manage all that power? With this new engine, the days of a gasoline or a propane engine lasting 100, 200,000 miles, those are gone. How does Ford ensure this engine that's going to run 3, 4, 500,000 miles?
Well, it's the durability that's built into the core of the engine itself. So making all that power and maintaining durability is a key feature of this. And you could see different pieces of that throughout the entire engine. So one example here would be the water pump. Seems pretty straightforward, but it's a heavy duty design borrowed from Ford's turbo diesel platform on the Super Duty. So it's borrowing a heavy duty bearing and everything from that lineup. You look at other features and attributes of it. So we have a chain driven variable oil pump that's located down here in the oil pan below the crankshaft. What that allows the engine to do is make higher oil pressure when it's needed. It also has advanced oiling on the entire valve train to give you maximum oiling on all of those valve components at low speed, low RPM, which is typically the medium duty and school bus duty cycle to a T.
Absolutely. And one thing we get asked about all the time are manifold studs, right? So what's different on this engine on regards to manifold studs versus the 6.8 liter?
Let's take a closer look. Manifold studs on the 7.3 liter have really been enhanced compared to the modular engine family. The M8 bolt that was equipped on the V10 is now become an M10 bolt on the 7.3 liter V8 for increased fastening power. You can see those located here. In addition, you only have a 4-runner exhaust manifold versus a longer 5-runner equipped on the V10, so less torsional force on the overall manifold itself and where it adheres to the head. But Ford didn't stop there. There's other heavy-duty attributes throughout the entire engine. We all know that cooling and lubrication is key to longevity and durability in an engine like this. So we look at some of the different things that are built in. Down here, you can see an integral oil cooler. So this allows the oil to be cooled regularly as it circulates throughout the engine, keeping the oil cool and then filtered on the opposite side of this with the oil filter. In addition, on the cooling side, there's cuts between the cylinder walls to make sure you've got adequate water jacket loop around the entire cylinder bore to make sure that you have even cooling on both sides of the engine and each of those cylinder walls to make sure, once again, we ensure maximum durability and longevity of the engine. But I think one of the main characteristics that really shows how tough and durable this engine is down here at the very bottom. So the crankshaft, which is located in this area, is where all that horsepower and torque from the engine is transmitted and ultimately pushed out throughout the entire powertrain of the engine. Ford uses a 6-bolt design on these main bearing caps, which hold this whole assembly together. So you can see 2 horizontal bolts, one on each side here on this deep skirt cast iron block, and then 4 vertical bolts going in and having a vertical tension load on it. This keeps a very rigid bottom end and can handle a lot of horsepower and torque for a very, very long time. The competitors in this segment only use a 4-bolt design, so a much more rigid design that we're seeing here on the 7.3 liter V8 from Ford.
Yeah, that's really going to make the difference when you get up into higher mileage applications. You know, run 3, 4, 500,000 miles, I don't think would be totally out of the question with this engine.
That's right. I think you can look through this entire engine, and whether we're talking about leaner, meaner, or cleaner, we could see how this overall engine has really delivered on all of those things. It's also delivered on the things that the key items that the customers wanted that have big fleets, right? They wanted simplicity. I think you're seeing it here with that 2-valve design. They wanted a more compact design. We've seen that with the overall reduction in width and the overall reduction in height, more compact to fit in those engine bays. So it really delivers on all of those key aspects that they were really driving at.
Yeah, I think with those features and benefits you just mentioned, this engine is going to be well placed to propel the Ford medium-duty platform and the Bluebird Vision well into the future. With a build volume of 600 to 1,000 per day and a long block available for purchase at less than $7,000, I think it's going to be a really great addition to a lot of fleets throughout North America.
I agree.
So I hope you enjoyed this 7.3 liter V8 walk around. If you want more information, you can visit www.roushcleantech.com or www.blue-bird.com.